Topic 3.4. We want to see if this is an even function or not. And I'm going to start off by converting the f of x temporarily to y. And we find if something's even or not by making all the x's into negative x's. So now I will change this into negative x to the fourth power minus 3 negative x squared minus 5. Once we change all the x's to negative x's, we then simplify. Negative x times negative x times negative x times negative x ends up being x to the fourth. Negative 3 times negative x gives us 3x squared, and then negative 5. Since this simplified back to the original, this is an even equation or function. This one is a function. Now, let's now check to see if the same function is odd. First, I'm going to convert this to y. So y equals x to the fourth minus 3x squared minus 5. And to check for odd, we change the x's and the y's into negatives. So this y gets converted to negative y. This x gets converted to negative x, then to the fourth, minus 3, negative x raised to the second, minus 5. Negative y simplifies to just negative y. Negative x times negative x times negative x times negative x is positive x to the fourth power. Negative 3 times negative x is negative 3x squared minus 5. And from here, we'll notice that it did not return back to the original. Even if we were to multiply or divide everything by negative 1, this still does not simplify back to the original, which should have been y equals x to the fourth negative 3x squared and a negative 5x. Instead, we get this. So nothing simplifies back to the original. So this is not an odd function. Now let's find the domain of these rational functions, or these functions, should I say. This is a rational function, and the rule for finding the domain of a rational function is to take the term out of the even function, set it greater than or equal to 0, and then we solve for x. I can solve for x here by, before I start the process of solving, I want to notice that this is greater than 0. This means that we're looking for positive parts of the graph. And we have an equal sign. This means we will have closed points. Alright, so let's go find those points. So x squared minus 9 equals 0. I can factor that into x plus 3, x minus 3. And then I can set x plus 3 equal to 0 and x minus 3 equal to 0. And this solves to be x equals negative 3, and this solves to be x equals positive 3. Okay, I'm going to put those two answers on a number line. And then observe. This is going to be closed, and this is also going to be closed. And we're looking for positive parts. So I'm going to use test points, let's say negative 10, 0, and positive 10. I'll put negative 10, let's see, we can put our negative 10 in the original. Negative 10 squared is 100. 100 minus 9 is a positive answer. So this matches. Let's put 0. 0 squared is 0. Take away 9 is negative 9. Negative 9 is a negative answer. So this area cannot be used. And positive 10 squared is 100. Take away 9 is still positive. Therefore, my solutions come from this area and this area because they match the positive, which means greater than 0. So my domain would be negative infinity to negative 3 with a bracket, union, this part, bracket 3 to positive infinity. Okay, let's take a look at the next one. We want to find the domain of number 7. We have two things. We have a rational, that's a fraction, and we also have an even root. The rule for rationals is that it's set not equal to 0. The rule for roots is that it's set greater than or equal to 0. When you combine both of those rules, we get 25 minus x squared is strictly greater than 0. No equal sign. Now, let's look at what we need. This is greater than 0, so we're looking for positive parts. And this is no equal sign, so this will be open circle. So let's take this off. 25 minus x squared equals 0. We're going to solve. And I get 5 plus x and 5 minus x. And I'll solve both these. 5 plus x equals 0. And 5 minus x equals 0. And I'm going to subtract 5 from both sides here. And I'm going to add x to both sides there. So what I'll get is x equals negative 5, and I'll get here 5 equals x. And those are my two solutions. I'll put those on the number line. Negative 5 and 5. Now looking back, they both will be open. And I'm looking for positive parts. So I'm going to test each one of these areas using negative 10, 0, and positive 10. Okay. If I square negative 10, I'll get 100. Then that'll become negative 100 and a positive 25. A negative 100 and a positive 25 is negative. And this portion cannot be used because we're looking for positive. 0 squared will be 0, and 25 minus 0 is positive. So this is positive. This is good because this matches what we're looking for. 10 squared is 100. Then this makes it negative 100 with a positive 25, which is negative 75. That's negative. So the only portion that's going to be positive is this right here. So that's where our domain will be. Our domain will be all the values between negative 5 and 5. Okay, here we have the same situation. We have a rational, which means it cannot be set equal to 0, and we have an even root, which means it must be set greater than or equal to 0. And when you combine those two, you'll have open, let's see, x squared, let's change colors on that, x squared minus 9x is greater than 0. Greater than 0 means we're looking for positive parts, and no equal sign means it's going to be open with a circle. So let's begin to solve that. X squared minus 9x equals 0. I can factor out the x. We'll get x minus 9, x times x minus 9 equals 0. And then I can solve this for x equals 0, and this x minus 9 equals 0. And this implies x equals 9. So those are my two solutions, 0 and 9. So 0 and 9. Okay, let's look back here. They'll both be open. Open here and open there. And then I need to test each area. I'll test this area with a negative 10. This area I'll test with a 5. And this area I'll test with a 10. Okay, so let's use this right here, this part right here. Negative 10 means x is negative. Negative 10 with a negative 9 gives me a negative. And a negative times a negative is positive. So this area is positive, so this matches. A 5. A 5 is positive. A 5 and a negative 9 is negative. So a positive answer times a negative answer gives us negative. And that's not what we're looking for. We're looking for positive. Let's try 10. 10 is positive, and a positive 10 with a negative 9 makes a positive number. So a positive times positive is positive. So this area is good right there. So let's write up the solution. the domain will be all the numbers within here, which is negative infinity to 0 with a parenthesis, union this portion right here, which is 9 to positive infinity.